Sorry for the break, students. So this is the continuation of the previous problem. Actually, you should have opened the problem number 13 in the textbook in front of you to understand how to solve this problem, isn't it? So I read the problem. It starts with a toy manufacturer preparing a production schedule. Actually, this video is just a continuation of the previous video which was interrupted between. Okay. So we are solving problem number 13, which will start with a toy manufacturer preparing a production schedule for two new toys, trucks and spinning tops. So we solve this problem here right now. Okay, the solution for problem number 13 from the PowerPoint in the textbook. So there are two different types of production. So this will give you an idea how what do you mean by LPP and how to use it in real life problems. Here we assume only two productions are given. So we assume X is number of trucks, number of toy trucks. Y is number of spinning tops. So we need to know how many units of toy trucks and how much Y, that is spinning tops, should be produced under the given constraints. See, we are not open to produce as much as we like. We cannot produce 100,000 million billion as we like. We have limited resources. We have limited availability of the machine and man hours. Of course, within this restriction we have to maximize our profit, isn't it? So we should try to get maximum benefit under this condition. That is the purpose here. So we are going to find the positive values of X and Y, no negativity. See, so that is the last condition we are going to write for the linear problem. So what is given in this problem? Read it again. There is a table given that's been given in this. There is a table given in this problem. Problem number 13. What is it? The first column reads machine A 2 hour 1 hour. Second column machine B 3 hour 1 hour. Third column finishing works takes 5 and 1 hour, isn't it? Okay, let's come back to this table, and before that we should finalize our objective function. How to find objective function Z to be maximized, because in this problem the question is to maximize. Read the problem at the end, you will find maximize in order to maximize the profit. So we are going to maximize Z, which is the cost of x1 and c. You should write cost of 1 unit of the toy and cost of 1 unit of the spinning top, toy truck and spinning top, isn't it? So what is given in the problem? Check at the end. See, if the profit is given as profit, not a this is not a cost C1, C2. In this problem it is given as profit. If the profits on each truck and spinning top are $7 and 2 respectively, can you find a statement there in the problem? At the almost the last but third row, if the profits of each truck and spinning top are, so the cost of the profit of the truck is $7 for 1 unit, and for spinning top it is $2. So our objective function has been finalized now, which is maximize Z 7x plus 2y. 7x plus 2y, isn't it? So this is the objective function. Now our aim is to find the values of x and y that will give you maximum value of z, isn't it? Maximum value. So that's our objective function. Now let us list out the constraint. See, as we have two products x and y, every product should undergo 3 machines. Machine A, machine B, and third is finishing work, maybe labor work, finishing work. So every product has to undergo all these three operations by machine A, machine B, and finishing work by laborers. And now we check the problem is given. For example, each truck requires. Oh, we will do this one. See, read the problem from the end of the second line in the second paragraph. Start from the second one. For operating machine A, 8 hours. So machine A is available for 8 hours, 80 hours. 80 hours, and machine B is available for 50 hours. For finishing work, labor hours are available for 70 hours. These three information have been given on the problem. You can check the problem. Read it one more time. Read it. The second paragraph. For example, each truck requires 2 hours on machine A. The available employee hours per week are as per week are as follows. So for operating machine A, 8 hours, 80 hours, machine B 50 hours, and finishing work 80 hours. This is the total number of hours availability of every machine, and finally the labor hours, isn't it? Now first column is for X, second column is for Y. Remember that. Now write down this one. Machine A, toy truck should undergo 2 hours in machine A, 3 hours in machine B. See, it's given the table. A truck against the row of truck. You read truck is our column X now. This is for truck. So whatever given in the row will be written here as columns. Truck. This is for toy spinning top. Spinning top. So for X, you see the row in the table reads 2, 3, 5. So 2x, 3x, 5x. What does it mean? If 1 unit of toy truck needs to undergo 2 hours in machine A, 3 hours in machine B, 5 hours for finishing work, then x units of toy truck should undergo 2x hours under A, 3x hours under B, and 5x hours under finishing work by laborers. In the similar way, you can write the second column, Y spinning top. Read the text question and the question in the textbook and check against that spinning top, second row. The row reads 1 hour for each. So 1 hour under machine, 1 hour under machine B, 1 hour for finishing work. This is 1y, 1y, 1y. So plus. So this 3 will give you the constraints, which is 2x plus 1y should be less than or equal to 80. I will explain why less than. 3x plus y is less than or equal to 50. 5x plus y less than or equal to 70. Why less than? Why not equality or greater than or equality? See, remember, the machine A is available only for 80 hours. This is per week in the problem, isn't it? So for 1 week, machine A cannot be utilized for more than 80 hours. Can be exactly utilized, all the 80 hours can be exhausted, or you can utilize less than the 80 hours. So the usage of the availability of A is 80 hours. So you use it for maximum 80 hours or less than that. That is why less than or equal to symbol comes here. If you are allowed to use more than 80 hours, it will be greater than 80, isn't it? So in this problem, all the constraints are here. This place will be replaced by inequality because you cannot use more than the available hours, right? So these 3 are our constraints subject to the constraints, TRAINTS, constraints. Now finally we will write x comma y should be greater than or equal to 0. The quantity should be always positive, isn't it? Greater than, can be one of them can be 0. You can ignore production of truck and go with the spinning top if that is the maximum for you, isn't it? So equality 0 is also allowed, right? So this is your LPP, linear programming problem. Now this part, there is an objective function to maximize there are constraints. The three conditions. Under this condition we should maximize our production. And finally, non-negative restriction. This is our linear programming problem that we are going to solve. Okay, now let us start the actual solution. Now we have converted the given paragraph into a linear programming problem. This is very important. So such problems will appear in your final exam, so make sure that you can convert the given problem into an LPP, and then we will use graphical method to solve this problem. So whenever there are only two variables, it is the only method, the easiest method is graphical method. And when there are more than two variables, we will study another method in the next chapter, which is called a simplest method. Let us solve this linear programming problem by using graphical method right now. Okay, let me write the objective function. What is the objective function? Maximize z is equal to 7x plus 2y, isn't it? And what is the condition? Subject to 3x plus y less than or equal to 80. Sorry, first one is 2x plus y. 2x plus y, and then 3x plus y is less than or equal to 50, and 5x plus y less than or equal to 70, and finally x comma y greater than or equal to 0. This is the given LPP. Now we are going to solve, isn't it? Okay, so what is the condition? We have to draw straight lines for every constraint. This is constraint 1, constraint 2, constraint 3, isn't it? We draw the straight line and choose the appropriate region, the solution region of every constraint, and then we will find the convex region bounded by these constraints, isn't it? And on the corner points of the boundary, we will find corner points, and then we will substitute the points in this z to find which point is the maximum point or minimum point. So maximum, in this case it's a maximum. So let me assume that this is rewrite this equation inequality 1. I am writing inequality 1 as y is equal to mx plus c. Y is less than 80 minus 2x. 80 minus 2x, isn't it? Now, what is x and y intercept from this one? When x is 0, you get y is 80. So y intercept is 80. When y is 0, what do you get? Y is 0, 80. Assume that this is equality and then solve it. Y is 0. Assume that this is equality and then solve it. Y is 0, so negative 80 divided by, so it will be 40. X is 40. So x intercept is 40, y intercept is 80. If you can write a straight line x over a plus y over b is equal to 1, the denominator of x is x intercept, the denominator of y is y intercept. This is also possible. You can divide this one by 80, divide this inequality by 80 and still get it. When you divide this inequality by 80 and instead of inequality assume it is equality, the right side is 1, x over 40 plus y over 80. So y intercept is 80, x intercept is 40. In any way you can find x and y intercept. So we can draw this one and the graph, isn't it? A straight line joining these 2 points. Okay, in the next we will go to graph after finishing all this. This is for first inequality. Second inequality. What is second inequality? So remember, first inequality x intercept is 40, y intercept is 70 on the graph, and then we draw a straight line joining these 2 points. Clear? Second inequality. What is it? Y is less than or equal to 50 minus 3x. 50 minus 3x. Now what is x-intercept or y-intercept? x0, when you take x equal to 0, y is 50. Y-intercept is 50. When you take y is 0, x-intercept is, this is negative 50, negative divided by negative 3, isn't it? 50 over 3. 50 over 3. What is it? What is 50 over 3? You can find by using your calculator, maybe around 16.7, isn't it? 16.7. Okay, something around 16.7, leave it. This is the x-intercept. Now third inequality gives third inequality from this one, isn't it? You'll get y is less than or equal to 70 minus 5x. 70 minus 5x. Therefore, when x is 0, you get y is 70. When y is 0, you will get y is 0, the negative 70 divided by 4. So x is 70 over 5, you will get 14. So x is equal to 14 is the x-intercept. 14. Y is 70. Now we are going to draw three straight lines representing the inequalities on the graph, and then we choose the appropriate area. Either we will see whether y is less than the right side or y is greater than the right side. And as there are inequalities with equalities, we need to draw dark lines, not a dotted line, isn't it? So this is what we are going to do on the graph, in the graph sheet. Now let's open the graph sheet. Okay, first remember, we'll be back whenever we want it. Okay. Okay, let's take this one now. First straight line representing the first inequality. One more time you can see. I just want to erase it. Yes, x-intercept is 40. You can call every unit as 10. This is 10, 20, 30, 40. Assume that every unit is for every unit is 10, 20, 30, 40, 50, isn't it? So you are here, x-intercept is 40, y-intercept is 80. So we need to draw a line that passes through these 2 points. You can extend it. Okay, fine. Now we know this is the line. This is the line. Y is actually, this is the line called y is equal to 80 minus 2x. So when you are looking for y is less than 180, this area is actually, remember one thing, we are discussing only the first quadrant. We should ignore everything in the other quadrants, isn't it? And here you remember first inequality is y is less than or equal to 80 minus 2x. You remember it? So less than or equal to falls below the line. So we don't want the area above the line. So we can remove the spot above this line. That's what happened for the first line. Now I try to change the color for okay, let the color be same. Why should I confuse you? Second line we are going to draw now. Okay, we are going to draw the second line. Fine. Second line, x-intercept is 16.7, y-intercept is 50. You go back and check. Second line is x. So every unit is 10 unit. Every unit is here for 10 units. Just 10, between 10 and 20, 16.7 somewhere here. 16.7 somewhere here, isn't it? And y is 50. It is here. 10 units. Everything is for 10 units. So we start a line through. This one, through this point, and properly we'll try it. You can extend this one. So second line, this line is called, this line you can call it by second constraint, which is y is equal to 50 minus 3x. So second constraint is actually y is less than or equal to 50 minus 3x. So less than the area is what we are looking for. We need to remove the area above the line. We need to remove the area above the line. Remove the area above the line, everything. So we are concerned about the area below the line, not above the line. Remove this part as well. And remember, we don't want the second, third, fourth quadrants. Let's go to draw the third line as well. Third line is, what is it? What is your third inequality? Third line, x-intercept is 14, y-intercept is 70. X-intercept is 14, again very near to this one, little bit downwards, and somewhere here. 14 less than 16. It was 16.7 previously, now 14 somewhere here after 10. Y-intercept is 70. You will come through this way. If possible, let me change the color. Okay, 14 is here and 70 is here, isn't it? Now let me join them. We extend the line to both the ends. This is the third line. We call it by y is less than or equal to 70 minus 5x. So we are looking for the area below this line. So all the above area should be again erased, removed. See, this is the convex region now. You will find this convex region here. The corner points appear here, 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 here. There are 4 corner points. Can you see? So the intersection. So draw some big graphs. You will understand that. So this intersecting this point is origin A. 0, 0, or call it the point origin. So we don't want this part. You remember, we don't want second quadrant, third quadrant. We want everything in the first quadrant because x, y greater than 0. Isn't it? So in this point is B, or call it A. Origin is O. This point 50. 0, 50. So this point A, this point B. What is B? From the graph it is 10 unit here, 20 unit here. From the graph we can find, or you solve second and the third lines to these two lines, this one. If you solve these two lines, you'll find the values of, algebraically you can find the values of x and y. Otherwise, from the graph, this x value is 10, this y value is 20, so 10, 20 is B. A is, so we write here, A is the point x is 0, y is 50. B is the point, this one intersection, 10 comma 20. C is this point on the x-axis. C is now we will expand this one. Okay, C is the point, this one 0 comma this point is actually 14, 14 here, right here, 14 comma 0. There are 4 points. Fourth point is 0, origin 0 comma 0. Oh, so let's go.